Hello students, welcome to the lecture. In this lecture we are going to discuss what is meant by the Jahn-Teller distortion and what are the types of Jahn-Teller distortion. As we know that when there is a unsymmetrical and symmetrical distribution of d electron in respective orbital, then when there is a unsymmetry in each orbital, then Jahn-Teller distortion may occur. Now let's discuss what is meant by the Jahn-Teller distortion. Distortion of highly symmetric molecule into unsymmetrical distribution in its ground state and excited state is known as a Jahn-Teller effect. So the distortion highly symmetric molecule due to unsymmetrical distribution of electrons in its ground state and excited state is known as Jahn-Teller effect. Degeneration generally occurs by lifting distortion generally occurs. Degeneracy orbital degenerate level. This Jahn-Teller is generally observed in tetrahedral and octahedral complexes. Now there are two types of Jahn-Teller distortion in octahedral complexes are generally formed. Let's see from that example. That is a ligand. There are 6 ligands here, that is B. This is B. This is A length and this is B length. If you observe that here, that is B length is greater than the A1. So that's why here the case first, that is A, B is greater than A, and in second, that is A, that is B, that is L. So here that is A is greater than B, so this is the case first. There are two types of distortion. There is elongation in this ML bond, so this is a B length, and there is a shortness in ML bond here, that is a length, so that's why B is greater than A, and here there will be the elongation in this ML bond, that is A, and there is a shortness in ml bond, that is a B, so A is greater than B. So these are two cases which are arised in octahedral complexes. Now let's discuss what are the types of Jahn-Teller distortion. There are two types of So here first, that is a dynamic Jahn-Teller distortion. First, then second, that is a static. First, we are going to discuss what is a static Jahn-Teller distortion. Discuss this structure, that is there are two cases in that is L. This is this is B. This is A1. So this is the type first, and here that is A. So this is a type second. So here that is A is greater than B, and here that is B is greater than A. So in these two cases, if you observe in static Jahn-Teller distortion, actually this static distortion is observed in this type second. Here these two bonds are longer, two bonds are shorter, whereas these four bonds are longer. Means that whatever the distance between this ml is greater than this ml, that is a B, so A is greater than B. So this is a 6. Actually these are the So if you observe that two structure here, that is a 4, generally 6 bonds are observed here, 2 are shorter and 4 are longer. These 4 are too much longer than these 2 bonds are shorter. So that's why here actually, so the in static distortion, the type second, two bonds are shorter and 4 bonds are longer as compared to regular tetrahedron. that is A is greater than B. So this case, so that's why this distortion is generally observed in D9 system. So this is a static Jahn-Teller distortion. Now let's discuss what is a, so these are all about the static Jahn-Teller distortion. Now discuss what is a dynamic Jahn-Teller distortion. Now in dynamic Jahn-Teller distortion, is observed in type first, that is in dynamic Jahn-Teller distortion, type first is observed. The energy difference in type first and second, in first and second is less as compared to regular octahedron. So whatever the energy between this first and second is very small, the energy difference between this first and second is very small. So molecule oscillating between first and second, and the time average form between them close to regular octahedron. So in static Jahn-Teller distortion, the type second generally observed, and in dynamic there will be the two energy difference between this type first and type second is observed, and this energy difference is very small as compared to regular octahedron, and then molecule is oscillating between type first and second. So that's why the dynamic Jahn-Teller distortion is observed in both. We can say that the energy difference between the first and second. So according to this dynamic Jahn-Teller distortion, so this dynamic Jahn-Teller is generally observed in D9 system, that is a copper plus 2. So if you observe the electronic configuration of copper plus 2, that is a D9 system, then there will be the three cases arises because there is a unsymmetry in EG orbital. So let's discuss. For example, if you take the example of copper plus 2 D9 system, so here that is a case first, case second. So in case first, that is a dx square minus y square. As we know that EG have a dx square minus y square orbital. So that is a 2 orbital for EG, that is dx square minus y square and dz square. So here there is a 3 electron, and how we can put up the electron in this EG orbital? So there are two ways, that is two cases. How many types of electron we can enter this EG orbital? So here, if you observe that there is a, if we observe that is a 1 electron in dx square minus square and 2 electron in dz square orbital. Here also we can write as like, that is 2 electron in dx square minus y square orbital, and dz square has only 2 electrons if you write. So here the total electron of this possibilities is 3. So we can write these are the two cases where the EG can acquire the electron in these two ways. There is a possibilities only. First case, the 2 electron, 2 ligand are upward and 4 are inward in case first, whereas the 4 ligands are inward and 2 are outward or the upward in case second. So these are the two possibilities of this Jahn-Teller distortion in D916. So this is all about the types and Jahn-Teller distortion. So we will stop here.